This video is to show you how to work a Gay-Lussac's law. By the way, it's also called John's law, in case you hear that term. But a Gay-Lussac law problem. And the trick to these is the same trick to any gas law problem that has temperature in it. And that is to make sure that you do not try and calculate it in Celsius. They have to be in kelvins. They are not directly proportional in Celsius, and it gives you the wrong answer. So I'm going to start just with the law itself. Which is P1 over T1 equals P2 over T2. So we have that. So we're going to need a P1, a T1, a P2, and a T2. And again, make sure your temperatures are in kelvins. So both of them here in this example are Celsius, but they have to be in kelvins. If you're unsure of that, try it and see. Once we have the answer, go back and try it in Celsius and see if it works, but it doesn't. Okay, so look at the labels. Everything in this chapter is about labels. If you know your labels, you'll know which variable is which. So the 46.8 is in kPa, and by now you know that's a pressure unit. Kilopascals. And then your temperature with that is 25.0 degrees Celsius. So we're going to add 273 to that. So 298 Kelvin. And then it says 134 degrees Celsius. So I know that's the temperature. Add 273 to that, and you should get 407 kelvins, which means pressure to is X. So I just set up that problem without actually reading through the problem. And you can do that usually. Sometimes you have to go in and see which one they're asking for, but it worked out. And then you're ready to solve it. So use the formula, 46 point, where'd my 8 go? There we go. 8 over 298 equals X over 407. Then cross multiply it. So multiply these two. You don't have to show this part, but I would like for you, speaking of what you should show, to at least show me this in your answer. Even if you don't show your let statements, show me how you filled it in and your answer. That's what I'm looking for mostly. Times 407 equals 298x. So multiply 46.8 times 407. And then divide both sides by 298. I'm getting 63.918. So I'm going to go back up to the top. This one has 3 sig dig, that one has 3 sig dig, and that one has 3. So I guess I'll do 3. So 63.9. And then it was a pressure, so it has to have the same label as the other one, so kPa. And you can leave it like that, or you can have it in the 6.39 times 10 to the 1 kPa. Either one. So those would be the two possible answers there. So hopefully this helps. Again, the big thing about gas laws is always making sure temperatures in kelvins. So give it a try. Remember, label your answer and round it to significant digits. That is key. Thank you. Have a good day.